So when you picture an engineer, what's the first thing that pops into your head? Probably someone in a hard hat looking up at a bridge or a massive skyscraper, right? And yeah, that's part of it, but that's like watching only the last 5 minutes of a movie. Today, we're going to rewind all the way to the beginning. We're going behind the scenes to see where it all starts, not on the job site, but deep inside the designer's mind.
So let's ask that question for real. What is an engineer? Is it just the person physically building the bridge? Or is it the mind that imagined it in the first place? The person who wrestled with physics and mapped out every single bolt and beam before anyone even broke ground? That's the world we're diving into today. That incredible mental process that takes a simple thought and turns it into something real you can touch.
And to really get it, we have to start by looking at how an engineer's brain actually works when they're coming up with ideas. And this isn't just guesswork, you know? There's some fascinating cognitive science here that shows how the different creative tools an engineer uses can literally change their patterns of thought.
Okay, so check this out. Research from Cambridge University looked at 3 main ways engineers generate concepts. First, you've got your classic brainstorming. Super intuitive, totally unstructured, just throwing ideas out there. Then there's something called morphological analysis. It's still intuitive, but it's a bit more organized. You break a problem down into its basic parts. And finally, you have TRIZ. This one is super logical, really structured, and it's all about finding inventive solutions by looking at patterns from past inventions.
And here's the thing that's so important to understand. Picking one of these methods isn't just about following a different set of steps. It actually changes the way the engineer's brain approaches the problem. It's kind of like choosing between a paintbrush, a chisel, or a 3D printer. The tool you grab is going to fundamentally dictate the kind of mental workout you're about to.
Now, this is where it gets really surprising. The Cambridge study measured cognitive load. That's basically just how much mental effort each technique takes. And get this, the most structured, most complex-looking method, TRIZ, actually required the least amount of brain power. It was the least demanding on the prefrontal cortex. So, what's going on there? Why is that?
Well, this quote right here pretty much nails it. The structure in a method like TRIZ basically acts like a roadmap for your brain. With brainstorming, you're just wandering through an open field of infinite ideas, which is exhausting. But TRIZ gives your brain a clear, step-by-step path to follow. That organized process is just way more efficient, and it frees up a ton of mental energy. And you can actually see how this plays out in the brain. It's like 2 totally different kinds of workouts. An unstructured method like brainstorming lights up the right side of the prefrontal cortex. That's the hub for creative, divergent, what-if thinking. But a structured tool like TRIZ gets the left side fired up, which is all about logical, convergent thinking, narrowing things down and making judgments. They are, quite literally, 2 different modes of thought.
Okay, so we've seen that initial brainwave, that creative spark. But how do you train a mind to have those sparks over and over, and to do it effectively? Let's move from that single moment of creation to the forge and see how an engineer's mind gets shaped over years of really tough training.
If you look at a top university like Imperial College London, their 4-year master's degree is a serious climb. Year 1 is just this intense deep dive into foundational physics and math. Then year 2 gets really heavy with coursework and trying to apply all that theory. By year 3, you start to specialize and learn essential tools like Python. And that final year, it's all about a master's-level research project. Each step is designed to build on the last, pushing you from just knowing stuff to being a real expert.
And let's be real, it is incredibly difficult. One student described their first-year fluid mechanics class as physics completely on steroids. So how do you even survive that? Well, the strategy is all about mastering the fundamentals. The advice you hear over and over from students is to just hammer the math, because that core knowledge is the foundation for pretty much everything else you're going to do.
So why would anyone put themselves through all that? This quote from an Imperial College lecturer, wow, it really puts it all into perspective. Civil engineers save more lives than medics. And when you stop and think about it, clean water systems, safe buildings, reliable infrastructure, it's true. This isn't just about building cool stuff. It's about building the very foundations of a healthy society. It's a job with a massive, often invisible impact.
You know, another huge lesson that comes out of the trenches of engineering school is that you absolutely cannot go it alone. That old macho man approach of trying to figure everything out by yourself, it just doesn't fly. Today's engineering problems are way too complex. Success comes from collaboration, from teamwork, from learning with and from your classmates. That's a skill that's every bit as important as knowing your calculus.
All right, so now we have this trained mind, forged in the classroom and sharpened through teamwork. How do you channel all that brain power into a massive, real-world project? Well, for that, you need a plan, a professional blueprint that can bring some serious order to all that chaos.
And in the UK, that blueprint is usually the REBA plan of work. Think of it as the industry's standard operating procedure. It lays out every single stage of a project, creating a common language that lets architects, engineers, clients, and builders all work together from the very first sketch right up to the final day they hand over the keys.
And this is what that life cycle looks like, boiled down to its essence. It all starts with the conception, that initial idea. Then it moves into the detailed design phase. That's where all that training and brain power gets put to work. After that, you've got the actual construction. And then finally, completion. It's this disciplined process that makes sure the initial brainwave actually becomes the final build.
Okay, let's connect all these dots. We've gone from the neural pathways in the brain through the demanding halls of a university and out into the structured world of professional work. So, let's go back to our big question. What is an engineer? When you look at the whole picture, the making of an engineer is really a story in 3 parts. It all starts with that creative spark, right? A specific way of thinking that can actually be shaped by the tools we use. That spark is then forged through years of intense training and teamwork into a powerful skill. And finally, all that skill is put into action through disciplined professional plans that turn these abstract ideas into the very world we live in. And that leaves us with one last, kind of mind-bending question to think about. We've seen that the tools an engineer chooses can shape their thinking in the moment. But what happens over a whole career? After a lifetime of constantly using these structured, logical, or intuitive methods, is it possible those tools don't just shape our ideas, but they actually start to reshape the very structure of our brains? Something to chew on. Thanks for joining me.